We all face these incredibly complex choices, right? In business, in finance, everywhere. There are just so many moving parts. But what if you could find the single best answer? Not just a good one, but the optimal one, mathematically guaranteed. Well, today we're going to dive into a tool that does exactly that.
So let's start with a classic problem. Picture this. You've got $70,000 ready to invest. You don't just want a decent return. You want the absolute best return possible. How on earth do you figure that out with total certainty?
Okay, so we're going to follow an investor who's facing this exact situation. She wants to maximize her profit for the year, but it's not as simple as just throwing all her money at the investment with the highest interest rate. Nope. She's got to play by a very specific set of rules. All right, let's take a look at her options. We've got municipal bonds at a pretty good 8.5%, a super safe CD at 5%, treasury bills at 6.5%, and then you see the growth stock fund, tempting you with a huge 13% return. I mean, the choice is obvious, right? Just put everything in the growth stock. Well, not so fast. Because that's just not how the real world works, is it? Investing, like pretty much any big decision, comes with constraints. These are the rules, the limits that really shape our choices and honestly stop us from doing something simple, but maybe a little bit reckless.
So, how do we solve this puzzle? We can't just guess our way through it. There are way too many combinations. The secret is to translate this real-world problem, all the words, the rules, the goals, into a mathematical model, something the computer can perfectly understand and solve.
The very first step is to figure out our decision variables. Now, that's just a fancy way of saying, what are the things we actually have control over? In this case, it's simple. It's the amount of money, the actual dollars and cents, we decide to put into each of those 4 investments. Think of them as the 4 knobs we get to turn.
Next up, we need to tell the model what we're actually trying to do. What's the goal? This is our objective function. It's kind of like the North Star for our problem. And for our investor, the goal is crystal clear. Make as much money as possible. We want to maximize the total return from all our investments put together.
And finally, we get to the constraints. These are the rules of the game. They represent all those real-world limits and conditions that our final investment plan absolutely has to follow. You can think of them as the guardrails that keep our decision on the road.
And here are the specific rules our investor is dealing with. First up, to manage risk, she can't put more than 20% of her total cash into municipal bonds. Second, she needs a solid foundation, so at least 30% has to be in treasury bills and CDs combined. Then there are a few other rules about balancing the portfolio. And here's a big one. Every single one of that $70,000 must be invested. No money left sitting around. Okay, so we've defined the knobs to turn, we've set our North Star, and we've put up all the guardrails. We feed this whole model to a computer and ask it to find the one single best answer. So, what did it come up with?
And here it is, the perfect portfolio. The single best way to allocate that money is to put 54.5% into treasury bills and the other 45.5% into the growth stock fund. But wait, look closer. What's just as important is what's not on this chart. The model is telling us to put $0 into municipal bonds and $0 into CDs. How about that? Even though they offered a return, given all the rules, they just weren't the best place for our money.
And the grand total from this perfect mix? A maximum possible annual return of $6,618.18. This is the power of optimization. Any other mix of investments that follows her rules will make less money. That is a mathematical guarantee. But hang on, because the answer itself is really only half the story. The real magic of doing this is that it doesn't just tell you what to do, it gives you incredible insights into why that's the right answer. This is where we unlock a much deeper understanding of the problem.
So, we followed all those rules, right? But were they all actually getting in our way? Which of those rules are the ones that are actively holding back our profit?
This brings us to a really cool concept called a binding constraint. The best way to think about it is like a rope that's pulled tight. It's a rule that you are pushing right up against the limit of. And if you could just loosen that specific rope, even a tiny bit, you could immediately get a better result. Other rules, well, they're like loose ropes. They're not really affecting you at all.
So for our investor, which ropes were pulled tight? Well, the rule to invest the full 70 grand was definitely binding. We used every last penny. The rule to have at least 30% in treasury bills and CDs was also binding. Our perfect solution landed exactly on that 30% mark. But what about the municipal bond rule?
no more than 20%. We invested 0, so that rule wasn't limiting us one bit. That was a loose rope. Now, knowing which constraints are the tight ones is super powerful. It lets us ask a much smarter question. If you had the ability to go back and negotiate, to just loosen one of those tight ropes, which one should you pick to get the biggest bang for your buck?
The answer lies in something called the shadow price. You can think of it as the bonus prize you get for relaxing a binding constraint by just 1 unit. For instance, what's the extra profit you'd get if you were allowed to invest just $1 extra above the $70,000? That bonus is its shadow price. And this is where it gets really useful. The chart here shows that not all tight ropes are created equal. The bonus prize, that shadow prize, for being allowed to invest $1 more is way bigger than the prize for lowering that 30% minimum rule. That's a massive strategic insight. It tells our investor, hey, don't waste your time trying to renegotiate your portfolio rules. You'd be far better off trying to find more money to invest.
Okay, let's explore one last piece of this puzzle. Remember how the model completely ignored the municipal bonds? That 8.5% return just wasn't cutting it. So a natural question to ask is, well, how much better would that return have to get for the model to even start thinking about putting money there?
This is where something called the sensitivity range comes into play. It's basically a safe zone for any of the numbers in your model, like an interest rate. As long as that number stays inside its calculated safe zone, your main strategy, in our case, only investing in treasury bills and the growth stock fund, is still the absolute best decision.
So for our municipal bonds, the analysis shows that its interest rate could be anything from 0 all the way up to 13%, and it still wouldn't change our decision. The current rate, 8.5%, falls right in the middle of that zone, which is why it got ignored. For it to become a contender, its interest rate would have to climb all the way past 13%, at which point it would finally be more attractive than the growth stock fund.
So let's zoom out for a second. We've gone from a simple word problem to a full-blown mathematical model. We've found the one best answer, and then we peeled back all these layers to understand why it's the best answer. This process is so much bigger than just one investment problem. So let's just quickly recap the big ideas here. First, optimization is this incredibly powerful tool for finding the single best solution when there could be trillions of possibilities. But it's not just about getting an answer, it's about understanding the why behind it. Binding constraints literally show you what's holding you back, shadow prices point you directly to your biggest opportunities, and sensitivity ranges tell you how stable your strategy is, even if the world changes a little bit. You know, this way of thinking, defining your goal, your choices, and your rules is a genuine superpower. It brings amazing clarity to really complex situations. So the question I want to leave you with is this. What complex decision in your world is just waiting to be optimized?